Okay, so now I'm going to talk about Caliper, which is not project. This is not even a micro project. This is merely a side effect of my work on VMs, Java, and optimization. So what is a Caliper? Caliper is a tool for writing and running micro benchmarks. So the goal is to make very simple, easy to use framework to, as I said, create and run micro benchmarks and then analyze the data. So let me show you how the benchmark looks like. Screen is so small. No problem. I'll manage. Well, no live programming now, right? So this is how the very simple benchmark look like. It's just a method which is annotated, right? You can run it. So, wow, that's not what I want to run, sorry. This is what I want to run. So now I'm running benchmark, and it, pretty much just to run the benchmark several times, and then spits out some files, right? So far, so good. But sometimes you want to know, how it scales. So you might want to set the different parameters. So this is, for example, a parameter, a number of iterations, number of runs of the main loop or something like that. You may define it like I want to run it just 10 iterations, okay? Or you might say, okay, I want to try how it scales, so just run it first time with a 50. Is it right? Yeah, 50 iterations, and second time 100 iterations, and just see how it scales. Sometimes the applications, if you run it multiple times or have different parameters, then there is some drop in a performance. So this is what can do, but then we found out that that's not enough. We need a database of the results. So the Caliper comes with a web application. No. With a web application that allows you to upload the results, and the web application stores them in a database, and then you can get the analyze afterwards, or retrieve the data and analyze them yourself, or it does a very simple graph analyzes itself. So this is, for example, the history. So what we have a Jenkins job that after each build runs a sequence of performance regression tests and keeps them. So we know that if we introduce some performance problem, then we will probably see a drop in this graph. Also, for example, it does another different view. One day I was told by Klaus Gittinger that, well, I think you messed up the perform. The perform performs really bad. Do something about it. So I write a simple benchmark, run it on 7 different versions of the virtual machine, run 7 different configurations, like different distribution of selectors and receivers and things like that. And then just upload the stuff, and you can very quickly see that this is probably the best combination, different algorithms used in Perform to optimize it. Okay, but then there is the optimization, and that's probably my favorite feature of this framework. Well, it's partially a feature of the framework, a partial feature of the VM. So with one single command line switch, you can run it you can run the benchmark under the profiler, and I mean a real profiler, not a message tolling, not a spy, a real profiler, right? And if you do it, the profiler spits out some file, and you can open it in a very nice tool, and you might get the results like that, right? So this is the result of the benchmark. And here you can clearly see that in add put there is a performance problem because we are jumping way too much. So probably I should rewrite this using some Go tool. And here I can analyze what are the problem. This problem in instruction fetches, or problem in Eliadna cache misses, and all these kind of things. When I was working in Java, that was hell useful. Okay, so that's basically what it does. We have a version for STX, we have a version for Faro, and we are planning to write pretty much the same framework, which consists just of, 7, 10 classes. We want to write it for Java and for Ruby and for Python to be able to compare the performance with those systems. That's pretty much it. Questions?
One very cool question.